Today on the Parallel Port, we're looking at a rack mount server made by Quanta. At $250, this bargain of a server seemed almost too good to be true. We'll be diving into it, showing you what we find, and determining if it's a great deal or not.
The package was delivered. This is the $250 Quanta server we bought on eBay. It's a 1U server, should be fully working. We selected CPU, 64 gigs of RAM, no drives, 10 drive bays, and I think it supports U.2 NVMEs, which is something I was looking for. So we're gonna open it up and find out.
Let's do it.
It felt a little shifty when I was moving the box around, so my hopes are not super high. All right, so.
Oh, wow.
So it is packed with expanding foam, but the foam didn't fully expand the entire volume of the box, but at least it's encompassed. Oh, wow.
Not really.
Okay. So looking inside the box, the server's just kind of sitting on a piece of foam in the front and just kind of sitting loose in the box back there. It did come with rails.
Let's go ahead and get it out and see if everything's intact.
All right, so here it is. This looks like a pretty deep server, which isn't uncommon these days. It's just over 29 inches front to back. Take a look at it on the front first. So we have this pull-out card, which gives us BMC MAC, and then there's a little diagram here that shows the ordering of the drives. So this is drive 0, 1, 2, 3, and so on. So it has the 10 bays. Nice little QCT cloud logo here. That looks cool. Obviously, it's great that the drive caddies are included. So let's pull out these and we'll pop some drives in these soon. Let's take a look at the rear. All right, so looking at the rear, dual AC power supplies. Looks like had a little damage here in shipping. But for a $250 server, if that's the worst that happens, I'm not going to be too upset. Not sure what the NIC setup is. So on the eBay order, we selected a gigabit OCP. Guess we'll see more about the NICs once we get inside. This NIC has a wrench icon, so this is probably the BMC IPMI. Then these ports are numbered 1 and 2. VGA, serial, and this is probably the add-in NIC we selected. So let's see how to open it up. I just see this one screw here, so I'm guessing it's the screw and then this push down. So if I push this down, there we go. Looking inside, it's a pretty deep system. I guess the simple things are the 2 CPU sockets. We have 2 DIMMs installed. We have 2 connectors for the front back planes. We can see the 3 NICs here are fixed on the main board, and there's a NIC under this storage controller. There's one open PCIe slot here. I think that's a PCIe 16. Interesting, there's a Broadcom battery pack here. But anyway, let's power it on and see what it does. All right. So we can see we have 64 gigs of RAM. That's good. So onboard LAN 1 and LAN 2 with Pixie. That's cool. Oh, interesting. It looks like we have a 10 gig Intel X540. I wasn't expecting that. And Avago Mega RAID. I'm just wondering how we changed the personality from RAID to something else like JBOD. Oh, and this explains the battery pack. So that's probably for the RAID card. JBOD mode. When enabled, the drive will come up as JBOD, else as unconfigured. Good. So maybe it will do JBOD now. So this says, okay, our MES card is 1 gig. It sees both processors. These are E5 2620V4s, hyper-threading enabled. Cool. All right, IPMI, BMC network configuration. So it looks like it's already set to DHCP. So we haven't plugged in the BMC NIC. We'll try that out later. It doesn't let us configure a username and password. So we'll have to see if this is a default or if we have to reset that later. And here are boot options. We can select legacy or UEFI. So one of the reasons I wanted to try this server is that it supports NVMe drives U.2 format. So most consumer NVMe SSDs are in what's called an M.2 format, which goes inside the computer. They work well, but they're not hot swappable.
We did an inspection on the backplane and storage cabling and found that only the first 2 drive bays are able to handle NVMe drives. Drive bays 0 and 1 can support either NVMe or SATA. They both have SATA and PCIe cabling in place. The SATA cables run from the backplane to the motherboard, and these 2 SFF8643 cables go from the backplane to motherboard PCIe ports for NVMe. The remaining 8 drive bays have SFF8643 connectors, one for drives 2 through 5 and the next for 6 through 9. On this system, they're cabled to the SAS3108 12 gigabit per second RAID controller card. The motherboard has additional SATA connectors, so it's possible the system could be set up for the remaining 8 drive bays to be cabled to the motherboard instead of a separate storage controller. We installed NVMe drives in bays 0 and 1, and in Debian, we're seeing them show up. Our first drive is a Samsung U.2 7.68 terabyte drive. A sequential read test shows 2,000 megabytes per second, and a write test is slightly behind at roughly 1,850 megabytes per second. We also inserted a few SATA and SAS drives in the remaining 8 drive bays, and were able to see those recognized by the SAS Mega RAID controller. We then connected the BMC port to our network, and it picked up an address with DHCP. But loading the login page is slow. The default login of admin for the username and password did let us in, and it took over 15 seconds after logging in for the UI to load. It shows BMC firmware 3.83 with a date from 2020. We tried, but were not able to find any firmware downloads for this server from Quanta's site. Looking at server health, we can see lots of sensor data, including the NVMe drive temperatures, and it shows we're currently using 112 watts. For remote control, there's only a Java console button, and it doesn't look like there's an HTML5 console. We only spent a few minutes on it, but the console was not working from Ice-T or Sun Java. With some more work, it's probably possible to get this working, but not having the console working in a browser is a pain. So if you just wanted to check the sensor data, the web interface is usable for that, but it's going to be much faster just to check using IPMI from the command line over the network. On the system board are 2 10G-base-T copper NICs powered by the Intel X540 controller. This controller is well regarded for solid performance, broad OS support, and features like SR IOV, which allows the NIC to be used directly by virtual machines. 10G-base-T is especially practical in a home lab since it works with standard Cat6 patch cables, avoiding the need for fiber or DAC cables. Additionally, the system has a PCIe Gen 3 X8 OCP mezzanine slot, offering several network expansion options. The card we have here is a dual-port 1GB NIC using the Intel i350 controller, which works fine for 1 gigabit speeds. However, if higher speeds are needed, there are several 10 gigabit and even 25 gigabit OCP card options. Many of these are available on eBay at reasonable prices. The OCP slot allows the primary PCIe slot to remain free for other expansion options, but there is a PCIe X16 slot for a full-height PCIe card like a quad-port NIC. This Quanta isn't excessively loud for a 1U rack mount server. These servers typically use small, high RPM fans that can generate significant noise. We're measuring around 73 dB, which is manageable for short periods but too loud for extended time in the same room. And the power usage is around 117 watts at idle in the current configuration.
Overall, this Quanta D51B server I think is a pretty good value as a home lab server. If you want to have a lot of SSDs, then the 10 bay small form factor chassis makes sense. The main drawback we found is just the BMC and not having a console that's usable in the browser. It does have BMC IPMI with a dedicated NIC, which is great for remote management, but not having a console you can use in the browser is kind of a pain. But there is a lot to like about the server, the drive bays. I really like the OCP mezzanine card slot and the options that gives you here for a NIC. And this is a functional server for virtualization at a really good price point. So I really like the idea of getting a couple of these machines, probably upgrading the NICs to 25 gig or 40 gig, interconnecting them all, and then making a hyper-converged virtualization cluster. I really would like to try that out with Proxmox and Ceph so that you have redundancy. There's a lot of options that gives you, and storage performance I think would be really good. If you've used a Quanta server before or have ideas for this machine, then certainly please let us know. We really want to hear your feedback. And if you've made it this far in the video, thank you for watching. Let us know, what do you think? Should we make more videos like this? Is home lab video something that's interesting? What do you want to see?